Hello students, welcome to today's physics lesson. Vector diagram of an AC series circuit. Imagine connecting a resistor, an inductor and a capacitor all in one loop and then applying an alternating voltage. What really happens inside the circuit? Let's break it down. When an AC voltage is applied across an RLC series circuit, the current that flows has the same frequency as the voltage, but not necessarily the same timing. We have learned that in a capacitor, current leads voltage by 90 degrees or pi over 2 radian. And in an inductor, current lags voltage by 90 degrees or pi over 2 radian. So what happens when we combine all three, resistor, inductor and a capacitor in one circuit? We should expect a phase difference between the total voltage and the current. To understand this clearly, we use a vector diagram, also known as a phasor diagram. The current is the same everywhere in the circuit, so we use the voltage across the resistor, VR, as our reference, because it is in phase with the current. VR is drawn horizontally. The inductor voltage, VL, points upward, 90 degrees ahead. The capacitor voltage, VC, points downward, 90 degrees behind. When we combine these voltages, the vertical component doesn't simply add, they subtract. And using Pythagorean's theorem, we get the total voltage V is equal to VR squared plus VL minus VC all square root. This can form a triangle. And from that triangle, we define something very important called impedance Z, which is the total resistance in an AC circuit. And the phase angle tells us, is the circuit more inductive or more capacitive? If XL is greater than XC, the circuit behaves more like an inductor. If XC is greater than XL, it behaves more like a capacitor. So in summary, RLC circuits are all about balance between resistance, inductance, and capacitance, and understanding how voltage and current shift with time. Example, which of the following graphs shows the correct vector diagram for the circuit above? We are given a circuit with an inductor L, a resistor R, and an AC source. This is called an RL series circuit. Here is the golden rule you must remember. In a resistor, voltage and current are in phase. This means the voltage across a resistor VR and current I point in the same direction. In an inductor, voltage leads current by 90 degrees. This means the voltage across an inductor VL is ahead of current I, points upward if current is horizontal. Let's take current I as our reference. Always draw it horizontal to the right. So voltage of the resistor VR, same direction as current I, horizontal right. Voltage of the inductor VL, 90 degrees ahead, vertically upward. Now look at the options carefully. We need current, horizontal right. Voltage across the resistor VR, horizontal right, same line. Voltage across the inductor VL, vertical upward. The diagram that shows this correctly is option C. Quick exam trick. Resistor, same direction as current. Inductor, voltage goes up. Capacitor, voltage goes down. Memorize this and vector diagrams become super easy. Next lesson, power in an AC circuit.